Good afternoon. It's a pleasure for me today to chair the specialization biogas and biomass energy in circular economic context. I will present today one subject and presentation about the biogas technology in the circular economic context. On a global scale, the circular economy represents only 80%, while the linear economy is still predominant, more than 18%. This low level of circular economy presence is mainly due to three interrelated factors that characterize the linear economy, namely high extraction rate, continuous accumulation of stocks, and low recycling rates. In order to achieve the objective of this circular economy, it's essential for the biogas plant to be able to close the loop in the integrate anaerobic digestion. This can only be achieved by suitable treatment of the digestate that allows sustainable and economically viable recycling of the digestate. In this case, an alternative solution for the digestate recovered must be considered. In this context, there are several systems that can solve this problem. These systems combine biochemical and thermochemical conversion of the biomass, and the calorific value of the digestate is not too low. This is in fact the case of most lignocellulosic biomasses, where the rate of biodegradability of the substrates in anaerobic digestion is not very high. Circular economy areas, we can distinguish three areas: waste management, supply from economic stakeholders, and consumer demand and behavior. In the waste management, we can notice recycling materials and organic materials. In supply from economic, we can have extraction, manufacturing, sustainable supply chain, eco-design, industrial and theoretical ecological. And then consumer demand and behavior, which link to responsible consumption. Circular economy business models in the value wheel. There are three circular business model categories at different value chain steps. First, design and manufacturing phase. The second step is use phase, and the last step is value recovery phase. Circular design models, optimal use models, and value recovery models. The role of solid waste in circular economy. You can see here all kind of treatment that we can use as option of solid waste management. Integrated all suitable energy to waste technologies in the waste management system. So we have to choose the best options, which depends on the waste nature, waste composition, climate, and so on. Food waste recovery in circular economy context. This is an example of using circular economy objectives in which we can have food waste to become resources dependent on the policy and the kind of technology we use. This is some opportunities and some limitations. conceptual empirical review studies, economic and social aspects, life cycle assessment, ILCCC and LCR. The current concern of scientists is the basis for circular economy and the optimization of the value of material flow. Policymakers and the public can be made more aware of the importance of circular economy through different life cycle approaches such as LCR and LCC and so on. Of course, the anaerobic digestion and biogas technology can contribute efficiently to the Sustainable Development Goals achievement. Among the 17 goals, biogas technology or anaerobic digestion process can impact in the second goals, zero hunger, the third goals, good health, 5 goals, gender equality, 6, clean water and sanitation, number 7, affordable for clean energy, number 9, industry innovation, number 13, climate actions, and number 15, life and land. So we can see that anaerobic digestion and biogas technology could contribute efficiently in the Sustainable Development Goals achievements. For example, in climate change, anaerobic digestion contributes to the reduction of greenhouse gas emissions using biomethane as sustainable biofuel for many purposes. It can also contribute to reduction the poverty in developing countries, mainly in rural areas. We can have many technologies from biomass energy or bioenergy technologies. Mainly we have two kinds, thermochemical conversion and biochemical conversion. We can sometimes, in order to achieve the circular economy, we have to combine the biochemical first conversion and then the thermochemical conversion for the digestate. That could improve the energy balance or the energy production. This is some scientific equipment in our university, which we use three kinds of digester: biofilm digester, C-star digester, and USB digesters. We try to determine the potential of some organic feedstocks to contribute to the promotion of biogas technology in Morocco. You can see here the hybrid system examples combining anaerobic digestion and gasification pyrolysis to close the loop. By anaerobic digestion, we produce biogas and digestate. The biogas is then upgrading to have biomethane for electrical or heat purpose, or using it as biofuel for transport purpose. Then the digestate can be separated in solid and liquid phase. The solid phase can be used in pyrolysis and gasification to obtain some important gases, syngas, such as hydrogen and methane. The liquid fraction of digestate can be used as nutrient recovery using alga products, water treatment, and in agri-waste to obtain finally lignosulfide pretreatment, to use it for this. As conclusion, the role of anaerobic digestion and biogas in the circular economy. In the future, bioeconomy waste will be transformed to high-value product and chemical building blocks, fuel, power, and heating. Biogas facilities will play a vital role in this development and in the implementation of novel production paths that arise in the transition to bioeconomy. The flexibility of anaerobic digestion system and its ability to digest a multitude of organic feedstocks while producing significant range of products ensure the role of anaerobic digestion in biogas in the circular economy. Thank you very much.